Hello everyone, myself Dr. Shitha Singhal and I am back with a very important topic about satellite communication, that is frequency ranges. It is very important to understand various frequency ranges to understand the subject properly. So we will learn various frequency ranges with the help of a very interesting simulation tool. This simulation tool helps us to understand various frequencies and their applications. Now we'll move towards the simulation tool. So this is the typical simulation tool. Let me explain one by one about various things and various components in this. Here you can see this shows the frequency. So as the frequency increases, you can see the wavelength will decrease and the waves will come nearer to each other. Here is the scale on which in this scale you can see various frequency ranges, and this box shows the various descriptions. So whatever thing is selected in this simulation tool will become orange, and you will get a description in this box, this box here. So let us see first what are the things, and then we'll change the frequency slider and see various effects of the frequency. So let us start with this magnetic field of Earth. So magnetic field of Earth is a natural phenomena, and due to it various static fields generate. So at 0 kilohertz we can see that nothing is happening, but only the static field is there. The static field is due to the accumulation of the electrons on one particular thing. So a compass needle aligns with the Earth's magnetic flux, and it always points to the magnetic poles. So we will change now this frequency slider, and we'll see another effect of this one. So as we change the frequency slider, so it is only having natural static fields. Natural static field is present in the mobile phones, and a mobile phone here, this one, it is a GSM device, and it transmits at 900 to 800 megahertz. It can receive in signals from the base station. So here the signals is shown for the mobile phone, which is working on 1 gigahertz, but we'll start from the beginning itself. From 0 we'll start. In 0 you can see that there is no frequency, and this is only for natural static field. So as we move forward, some frequencies has started, but this frequency is not very useful. Then this is low frequency. Here this is low frequency. This is low frequency, and low frequency is used for railway current. You can see that the railway lines have turned orange, and the railway tracks has also turned orange. Then we move forward. Then around 230 kilohertz. This is the power from the grid, and it is also low frequency. So at 1 kilohertz you can see that the frequency has started taking shape, and it is comparatively more high speed. So we further move the slider forward, and we see what are the functions. Now this is the long wave. So high frequency, this is a high frequency wave. It is not displayed in the simulation tool. So this high frequency is generally used for short wave radio and radio telephony. Now AM radio, this is again a high frequency, and this is not displayed in this one. Now short wave, this is again high frequency, and it is also not shown. It is used for short wave radio and radio telephony. Now FM radio, this is high frequency. Here we can see that this is the FM radio. We were up to FM radio. Now this is GSM cellular telephony. You can see that GSM tower on the top of the house is orange, and the mobile phone in the hand of the person is also orange. So this shows that this is the use, and you can see the frequency is higher. Now as we move further, so this is a higher frequency, greater than 1 gigahertz, and this is for radar high frequency. Orange box there is nearby the road is used for measuring the speed of the vehicle. It is based on the principle of radar. Now as we further move, so the frequency is getting more higher, and we can see now we have reached to the infrared radiation. It is coming from the sun, you can see, and some of the towers are also emitting infrared radiations. So more high, we go more higher here. So now this is the visible light region. You can see that lamp post has turned orange, and the sun has also turned orange. Now furthermore we are going. So this is ultraviolet radiation. This is emitted by the sun, and some of the tower is also emitting ultraviolet radiations. And finally this is very high frequency. We are reaching toward the radioactive gamma rays. So radioactive gamma rays are emitted by this nuclear power plant and nuclear decays of uranium and other radioactive substances produce heat used for production of electricity. Now we'll see one by one the components which are there in this figure. So this is the mobile base station tower. Base station mostly consists of 3-sector antenna, and each antenna focuses its radiation onto a specific spatial sector. The strength of the field at the specific location depends on the factor like directivity of the antenna, power of the antenna, and the nearby objects that are obstructing it. The electromagnetic field is very weak outside the main beam. So we'll see some other thing. Now this, I have told you, this is speed radar. This speed radar measures the speed of cars which are passing through this road. Now these lamps, these are lamps that current is converted into visible radiation, and they convert electric energy into light energy. So these are the fridge. So these are not connected to the grid, so these apparatuses are not plugged into mains. So these are not emitting any electronic or magnetic fields. Now this is the TV tower. This TV tower emits high frequency EM waves. Now these are the clouds. Clouds will also get activated. These are the clouds, and they will come back again. We'll select them. This is a nuclear power plant. Nuclear power plant emits this radioactive waves, and due to the decay of uranium and other radioactive substances, and it's released lots of thermal energy and gamma rays. So this is highlighted here. You can see. Now this we know that this is sun, and this is the this emits ultraviolet light, visible light, and infrared light, and this is the source of every energy. Now this is my mobile based phone tower. This we have already covered. Only the clouds are remaining. As soon as they come, we'll select them. So here they are. They will be selected here somewhere. For the static energy, they will be selected. See. For natural static field, we can select the clouds also. So this is a very good simulation tool. It gives the idea about various frequency ranges. To sum up, I will give you what are the frequency ranges. 30 to 30 kilohertz, it is VLF, and it is used for maritime navigation signal. 30 to 300 kilohertz, it is low frequency, and it is used for navigation aids, LoRaWAN, etc. 300 kilohertz to 3 megahertz is medium frequency, used for AM and maritime radio. 3 megahertz to 30 megahertz is high frequency, used for shortwave radio telephony. 30 megahertz to 300 megahertz is VHF, used for VHF TV, FM radio, navigation aids. 300 megahertz to 300 gigahertz is UHF, used for UHF TV, cell phones, GPS. 3 gigahertz to 30 gigahertz is SHF, that is satellite or microwave communication. For satellite communication, this is the most important band. This band is further expanded into L 1 to 2 gigahertz, S 2 to 4 gigahertz, C 4 to 8 gigahertz, X 8 to 12 gigahertz, and K band is split into K under and K above. So KU 12 to 18, K 18 to 27, and KA 27 to 40, and V band 40 to 75, W band 75 to 110, and then comes the millimeter wave 110 to 300. So similarly, next is 30 gigahertz to 300 gigahertz, that is extremely high frequency. It is used for radio astronomy, radar based systems. So I think this simulation tool was very helpful, and it makes it clear about various frequency ranges. You can see the importance of the frequency. As the frequency change, mode of the communication also change. If you are in lower frequency side, then it is analog communication. If you are in higher frequency side, then it becomes wireless communication. We further move towards the higher frequency, then it becomes microwave communication. Further higher frequency, it becomes satellite communication. Further higher frequency, it becomes optical fiber communication. So frequency range is very important. This simulation tool explains it very naturally. Thank you for listening patiently. We will be back with another interesting